Hello, chemists. This is Ms. Placino, and you're watching lesson 12.7 on the hydrolysis of salts. In today's lesson, we're going to talk about how to determine if a salt, that's just another name for an ionic compound, is acidic, basic, or neutral. Goals for today's lesson. You should be able to determine which acid and base reacted to produce a salt. And then based on that information, you should be able to predict the relative pH of a salt. Really, is it going to be acidic, basic, or neutral? Let's get started. The last two lessons have focused on neutralization reactions, specifically Arrhenius acid-base neutralizations. So we know that when an acid and a base react, we're going to produce a salt and water. The salt hasn't gotten a whole lot of attention, but that's where we're going to focus our energy today. We know that based on the strength of the acid and the base, we can determine the equivalence point of the neutralization. So we talked about like strong plus strong yields neutral. A weak acid plus a strong base yields a basic endpoint or equivalence point, and a strong acid plus a weak base gives us an acidic equivalence point. What we want to think about today with the salt is kind of working backwards to determine which acid and base must have reacted to form it. And that's going to be at the heart of predicting whether the salt is acidic, basic, or neutral. Right. So again, we're going to work backwards to determine which acid and base were reacted. We know that the cation is going to come from the base. It has to. Think about it. With our acids, the cation is always H+. Our anion must come from the acid. In a base, the anion is always OH-, so that the anion that's going to form the salt is going to be produced by the acid. I'll actually jot that down. So when we've got the salt, we want to kind of work from the formula to get back to the original acid and base that must have reacted to yield that salt. And then based on the strength of the acid and the strength of the base, we can predict whether the salt is acidic, basic, or neutral. Let's look at an example together. We'll start with one that hopefully you're familiar with, NaCl. All right, so we know that the cation has come from the base. And we know that the anion has come from the acid. What base would sodium be present in? Well, we're looking at Arrhenius acids and bases. So an Arrhenius base is going to take my cation plus hydroxide. So the sodium must have come from sodium hydroxide. We'll kind of go through the same thought process with the Cl- ion. We know that chloride must be produced by the acid. What acid do we know will dissociate to produce chloride ions? That has to be HCl. Okay, so the kind of difficult chemistry aspect of this problem is over. You've identified your acid and your base. Now we have to think about the strength of the acid and the base. So again, for the millionth time, if you haven't memorized your strong acids and bases, what are you waiting for? It's really going to be helpful for questions like this. Sodium hydroxide is a strong base. It is a group 1 metal combined with hydroxide. HCl is a strong acid. It's going to dissociate completely when dissolved in water. So I've got a strong acid plus a strong base. That should yield a neutral salt. That means if I was to take sodium chloride, dissolve it in water, stir it up, and then measure the pH of that solution, it should have a pH pretty darn close to 7. It's been strong acid, strong base. They kind of cancel each other out effectively. So you should get a neutral, we call it a neutral salt. And again, it would produce a solution with a pH pretty close to 7. In class, we'll go through and actually, test the pHs of these 5 substances. But what I'd like you to do is kind of just walk through the thought process. See if based on the formula of the salt, you can work backwards to figure out which acid and base were reacted to form it. Remind yourself whether that is a strong or weak acid or base, and then based on the strength of the acids and bases, should that salt be acidic, basic, or neutral? So let's walk through one together. PbNO3 2, so lead 2 nitrate. I know that the anion, in this case the NO3, must come from the acid. NO3 is a polyatomic ion with a charge of -1, so my acid must be HNO3. Nitric acid. Is nitric acid a strong or weak acid? If you are flipping back in your notes, you have not memorized these yet. Nitric acid is strong. We know that the cation comes from the base. In this case, lead has a charge of +2, and that because my subscript for nitrate is 2. All right, so my base must have hydroxide. This must be lead 2 hydroxide, or Pb parentheses OH2. Is that a strong or weak base? Well, let's see. Strong bases come from group 1 or group 2 metals combined with hydroxides. Lead is definitely not a group 1 or group 2 metal, so this is likely a weak base. If I take strong acid plus weak base, I should end up with an acidic endpoint, meaning that the salt would also be acidic. If I was to take some lead 2 nitrate and dissolve it in water and then test the pH, I should end up with a pH less than 7, an acidic pH. Pause the video, try it out, go through and name the acid. You can write the formula for the base, tell me the strength, and then predict acidic, basic, or neutral endpoint. And we'll review once you've got them. All right, sodium carbonate. It must have been carbonic acid, which is a weak acid, and sodium hydroxide, a strong base. So weak acid, strong base, that's going to give me a basic salt. If I dissolve sodium carbonate in water and test the pH, it will be greater than 7. Then we have sodium acetate, so that's acetic acid, CH3COOH. That is also a weak acid. Remember, that's what the active ingredient is in vinegar. You would not want to consume a strong acid. That'd be dangerous. Again, sodium hydroxide is the base. It's still strong. That should also be a basic salt. Sodium sulfate, Na2SO4. That must be sulfuric acid, H2SO4, which is a strong acid. Sodium hydroxide is my base, also strong. So I should have a pretty neutral endpoint here. And last, we've got zinc nitrate. Again, nitric acid, a strong acid, is the acid that must have been present to produce the salt. The base, Zn parentheses OH2, zinc hydroxide. Not a group 1 or group 2 metal, so that's going to be a weak base. So if I've got a strong acid and a weak base, that should give me an acidic salt. So if I dissolved the zinc nitrate in water and tested the pH, it would be below 7. All right, hopefully this is kind of starting to make sense, and we can see that it's really just a different way to apply kind of what we talked about in the previous lesson with picking indicators. So you've got a bunch of practice problems in your notes to play around with. Keep working on this concept and go back and review titration curves if needed. All right, that wraps it up for today. Thank you for tuning in, and I hope you found this helpful.